Okay, way back in geometry, whenever you had a right triangle and you have an angle inside the triangle, we learned special names for the sides relative to that angle. The side across from the angle we call the opposite side. The hypotenuse is always the side across from the right angle. It's always the longest side. And the adjacent side is what we call the side that's touching the angle that's not the hypotenuse. And you all learned something called SOHCAHTOA. Not sock it to me, Will, but SOHCAHTOA. And Tyler, what were you saying SOHCAHTOA was?
Sine, cosine, and tangent.
Yeah, it's a mnemonic device to help us remember the values for sine, cosine, and tangent of that angle. So sine of theta is going to be opposite over hypotenuse. Cosine will be adjacent over hypotenuse. My pen is still acting up a little bit. Let's try to ignore the stray marks. And tangent is opposite over adjacent. All right. Now, I told you we would learn 6 trig functions. That's only 3. Where are the other 3 going to come from? Well, they're going to be related to these 3. The first one we're going to call cosecant. C-O-S-E-C-A-N-T. And we abbreviate it CSC. And cosecant is the reciprocal of sine. So if sine is opposite over hypotenuse, and cosecant is its reciprocal, cosecant will be hypotenuse over opposite. Okay. The reciprocal of cosine we call secant, S-E-C-A-N-T. And we abbreviate it, not B-I-G-1-0, but S-C-C. So we read that as secant. It's the reciprocal of cosine. It's going to be the hypotenuse over the adjacent side. That's right. And tangent, its reciprocal, we're going to call cotangent. And its abbreviation is going to be COT. We don't pronounce it cot. We actually say cotangent. And that's going to be the adjacent over the opposite side.
Do you have to memorize these?
Yes. You're going to use them so frequently. Sorry, I don't mean to be in your way. You're going to use these so frequently, it's not going to be much work on your part. Okay. All right. So those are my 6 trig functions: sine, cosine, tangent, cosecant, secant, and cotangent. Okay? So let's see how this is actually going to work. Say I've got this right triangle, a 5, 12, 13 triangle. And I want all 6 trig functions for that angle. So I want, let me start with sine. So I want the sine of theta, the cosine of theta, the tangent of theta. I also want the cosecant, the secant, and the cotangent. Okay? What was sine? Opposite over hypotenuse. So here's my angle. The opposite side is 5. The hypotenuse is 13. So it's going to be 5/13. Okay. Cosine. So toa, AH. Adjacent over hypotenuse, 12/13. And tangent. Opposite over adjacent, toa, toa. Opposite over adjacent, 5/12. Oops. Now, for cosecant, secant, and cotangent, they're just reciprocals of sine, cosine, and tangent. So if sine is 5/13, cosecant will be 13/5. Hypotenuse over opposite, 13/5. Secant will be the reciprocal of cosine. Cosine was 12/13. Secant will be 13/12. Hypotenuse over adjacent. Cotangent, reciprocal of tangent. Tangent was 5/12. Cotangent be 12/5. Adjacent over opposite, whereas tangent was opposite over adjacent. Okay? That's all there is to it. Those are your 6 trig functions. Okay? Now, what if you have a triangle where you only have 2 sides? Like this one. How can I find that third side?
You have to find it by doing the opposite, or doing...
Well, I've got a triangle with 3 sides. I know 2 sides. It's a right triangle. I need that third side.
A plus B plus C.
Yeah, I need the value of x. I'm hearing A, B's, and C's. A squared plus B squared is C squared. What's that called? Pythagorean theorem, right? And you guys learned this in, I don't know, 6th, 7th, 8th grade, as A squared plus B squared equals C squared. I don't like that as much as I like leg squared plus leg squared equals hypotenuse squared. And the reason why is this. When you first learn the Pythagorean theorem, you're almost always solving for the hypotenuse. Leg squared plus leg squared, A squared plus B squared gives you C squared. But in this one, we're not looking for the hypotenuse, are we? We're looking for a leg. And the common mistake students will make, they'll say x squared equals 10 squared plus 5 squared, and go from there. And they're going to get it wrong. Right? Because your C is always the hypotenuse. So don't make that mistake. Well, come on now. All right. So I've got leg squared plus leg squared equals hypotenuse squared. 5 squared is 25. 10 squared is 100. Subtract 25 from each side. I have x squared equals 75. But I wasn't looking for x squared, was I? No, I want x by itself. What's that? Yeah, I need to square root each side. So x is the square root of 75. Now, usually when we take square root, we take both the positive and the negative square root. But x is a length, and you can only have a positive length. So we drop the negative square root. And 75, that radical will reduce. The calculators I just gave you, I don't know if it will reduce a radical or not. I honestly don't know. They're brand new to me. Type in square root of 75 and hit it. And does it give you a decimal or a reduced radical? A decimal. Okay, so we've got to reduce this radical. Now back in 7th grade, when you guys were reducing radicals, often you would make a factor tree. Something like that. Right? You can do that if you need to. I'm not that big of a fan of it. What I prefer is asking myself if 75 has a factor that's a perfect square. Yeah, 25. Very good. And what times 25 gives me 75? 3. Okay. And I can't take the square root of 3, but I can take the square root of 25, which is 5. So it will reduce to 5 root 3. So my x is, let me make that more clear, will be 5 root 3. Okay? Sure. Oh, scroll down?
Yeah.
I'm sorry, I thought you said slow down. And again, my pen's all messed up. That's an equal sign. That should be an equal sign. Okay, now I made it look like a negative. Okay? All right. So now I can find my 6 trig function since I have that missing side. Sine opposite over hypotenuse. Oh my goodness. Five root 3 over 10. And what can I do with that? I can reduce it.
You can go ahead and get your CS.
To root 3 over 5. Okay. Cosine adjacent over hypotenuse. That would give me 5/10. And that will reduce to 1/2. And tangent opposite over adjacent. 5 root 3 over 5. Opposite over adjacent. My 5's will cancel. And my tangent is just root 3. Yes, ma'am.
Why is there a 5 on the bottom of the sine one instead of a 2?
Oh, you got me. Because I'm talking and writing at the same time. Getting all tripped up. There you go.
Hey, you want that?
You know, it's, yeah, I know 10 divided by 5 is 2. Don't think I don't. You're up here, you're talking, you're thinking about what you're going to say next. You're going to make a little mistake now and then. That's okay. So those are 3 of my 6 trig functions. Now I need to find the other 3. What do we call the inverse of sine?
CSC.
Cosecant. Abbreviated CSC. And it's the reciprocal of sine. And sine was root 3 over 2. Cosecant will be 2 over square root of 3. Now, we get to a topic that students really don't like when we come to it, called rationalizing fractions. Is there an issue with that fraction?
Yeah,
What's the problem?
you can't have a square root in
Yeah, you really, Will said you really don't want a radical in the denominator. In general, the math world is getting away from that. However, we still need to hold to that. When we get to the unit circle, we're going to have rationalized values all the way around the thing. So we're going to have to get handy at rationalizing. So I want to get that square root out of the denominator. And I can do that. I want to get rid of that square root of 3. If I multiply by square root of 3 over the square root of 3, whatever your square root is in the denominator, multiply it by that same square root over itself. Root 3 over root 3 has a value of 1. I'm multiplying by 1, so I'm not changing the value of 2 over root 3. Okay? 2 times root 3 is just 2 root 3. Square root of 3 times square root of 3. When you multiply radicals, what's the rule? When you're multiplying square roots, you can multiply the numbers under the radical together. 3 times 3 gives me 9. But it's still under the radical. And the square root of 9 is 3. So that eliminated the radical in the denominator. It's called rationalizing fractions. All right, now I need secant. Secant is the reciprocal of cosine. The cosine is 1/2. What's the reciprocal of 1/2?
2 over 1.
2 over 1 or just 2. Okay. And reciprocal of tangent is cotangent. My tangent was root 3. So it's going to be 1 over square root of 3. And I've got to rationalize again, don't I? So I just multiply by root 3 over root 3. 1 times root 3 is root 3. And we saw square root of 3 times square root of 3. It's going to end up being 3. Okay. So those are your 6 trig functions given a triangle with one side missing. First we had to find the missing leg. Then we had to plug into our formulas. And we had to do a little bit of rationalizing. Okay? Those are the 6 trig functions. Thank you. Oh, no. That's too much.